recording. I'm using a new screen recorder. Alright, so you had the back page to do. Bill weighs 120 pounds, gaining 10 pounds each month. So we know he's 120 pounds for sure. And he's gaining 10 pounds per month, so 10 times M. Phil gaining 150 pounds a month. Sorry, Phil's 150 pounds a month. But he's gaining 4 pounds each month, 4 times M. So, when will they both be the same weight? Well, hopefully not too far down the line. Let's do minus 4M on both sides. That's 6M, so 120 plus 6M equals 150. Minus 120 on both sides. 6M equals 30. Divide both sides by 6. And 5 months, both Bill and Phil will have the same weight. Alright, so far so good. So we have a Coca-Cola can, which is full, so there's 355 milliliters in that Coca can, but it's leaking, so minus 5 milliliters per minute. So it's losing 5 milliliters per minute. So that's the equation that describes what's happening with that Coca-Cola can. The other Coca-Cola can, right, it's empty, so it starts at 0. There's 0 milliliters in the can, but it's gaining how much? It's gaining 5 milliliters per minute. Every minute it gains 5 milliliters. So now that 0 we don't need, and so I'm just going to take that off, and maybe I can move this 5M. Right, so that would be my equation. So one can is full at 355 and is losing 5 milliliters per minute, and the other one is at 0. It's empty can and it's gaining, right? So when will they have the same amount of Coke? When would the Coke that's leaking and the Coke that's gaining have the same amount after how much time? So minus 5M plus M, so let's do plus 5M here, and we'll do plus 5M on this side. That goes away, 355 comes down, and we get 10M. Divide both sides by 10. And M equals 35.5 minutes? No. Something wrong here. Divide by 10. 35.5. 1 milliliters. Okay. It's a very small leak. Okay, so after 35.5, minutes. The problem with the screen recorder is that makes my pen lag after a while. So hopefully you won't notice the lag, or I won't notice the lag. So here's my pen. Saturday, you bowl at Mars, so you rent the shoes. So remember, when you rent the shoes, you pay $2, and that's it. The shoes are with you for the whole night, no matter how many games that you play. So you pay one time $2 shoes, but every game you play, you pay $3.50 times G per game. On Sunday, you go somewhere else and they charge a little bit more for shoes, but each game they play is $3.25. So if you spend the same amount at each of the bowling alleys, how many games were bowled? Well, I forgot the G over here. So we're going to do minus 3.25 G. Minus 3.25 G. That goes away. We have 5 over here, and this is 2 plus, what is this? 0.25 G. We're going to do minus 2 on both sides. And we're going to get 0.25 G equals 3. And then we're going to divide both sides by 0.25. And G equals 12. So you played 12 games, which is a lot. Okay, which is a lot. Let's see. One store trophy costs $12.50. Engraving costs 40 cents per letter. So you're gonna pay $12.50. Plus, you're gonna pay 40 cents per letter. And let's write X. I don't like the letter L. On the other store, it's the same trophy, costs $14.75, plus they charge a little bit less for the letter 0.25x. After how many letters will you be paying the same price? Well, okay, so let's get rid of the small one. So it's 0.25x subtracted from both sides. And my pen is lagging. Equals 14.75. So these two will go away. Here we have 1250 plus 0. That's a 2, by the way. That's going to give you 0.15x. I'm going to subtract 1250 from each side. And we're going to get 0.15x equals, what is that, 1250, sorry, 1250. So we get 2.25 left over here. And 2.25 divided by 15, it should be 15 letters exactly. 2.25 divided by 15, yeah, it's 15. So divide both sides by 0.15. 0.15. So if you write exactly 15 letters on the trophy, then it doesn't matter which of these two stores you go to. You end up paying the same price. Okay. $11. You want to be emancipated from your parents. You're looking for an apartment, so they're not going to pay anything anymore for you. You're going to take full charge for your expenses. Apartment A. You look at two apartments. One apartment is $1,000 plus $1,200 per month. All right, which is not bad. The other one is $1,500 deposit plus $1,175 per month. So one might be cheaper, the other one be obviously depending on how long you stay. But if you're staying this amount of months, it doesn't matter which apartment you stay with because they both cost the same price. So, but we have variables on both sides. Let's get rid of the small one, which is this guy. That's gonna go away. We're gonna have 150 left over here. 1,000. What is this? Second, guys. Oh, that's a 500. I forgot. It's 1,500. Sorry. So plus 25m. Subtract 1,000 from each side, and we're left with 25m equals 500. And divide both sides by 25. M equals, let's see, 4 times 500, not 5,000, sorry, that's 500. 20. Okay, so after 20 months, both apartments cost eventually the same price. Then he makes 50,000, 55,000, and it gets annual raise of 2,500. Carl makes 6,200, gets annual raise of 2,000. After how many years will it take for them to make the same salary? So one guy's making $55,000, and every year gets a $2,500 raise. So let's call that R. The other guy makes $62,000, and he makes gets raises of $2,000. So although one person starts with a higher rate, higher what do you call it? Salary, eventually this guy over here will catch up. But let's see how many years it takes. Let's do minus $2,000 on both sides. And we're going to get, that goes away, 62,000 comes here. This is 55,000 plus 500R. We're going to subtract 55,000 from both sides. And we get 500R equals, what is this, 7,000? Divide both sides by 500. R equals 14. Okay, so after how many years? Oh, I should have used the what do you call the variable y. So this should have been y, by the way. It takes 14 years for Lanny to catch up to Carl. So it's up to you where you want to work, right? Would you work with the same firm as Lanny, or would you work at the same firm as Carl? So if you work with Lanny, after 14 years, he eventually catches up to Carl, and then after 14 years, Lanny starts making more money every year, right? But yeah, you have to wait 14 years for that, which is a pretty long time. All right. What is this? In 1987, 34.7 million owned the dog and 27.7 owned the cat. Since then, dog ownership has decreased and cat ownership has increased. How many years? Why will it take them to be equal? Oh my god. So again, this is like no other problem. So it's 34.7 million. Okay, and so we start with 30.7 million dogs, and then we're gonna subtract 0.025 every year are lost. And then on the other side, cats, you start with 27.7 million, but we're increasing the number of cats. Number of cats increased by 0.375 per year. So when will these two be equal? Well, let's add this to both sides to get rid of that. That goes away. We got 34.7, and then here we got 27.7 plus, what is this? 0.3. Why? Minus 27.7 on both sides. And we get, what is that? 0.7 equals 0.35. Y, divide both sides by 0.35. And y equals, what is that, 20? 7 divided by 0.35. Yep. After 20 years, number of cats, number of dogs will be the same. Alright, one more. In Ohio, the population was 11.4 and increasing. Michigan was 9.9 and increasing by 6.6. When will the two states have the same population? So Ohio starts with a little bit more and increases by 0.5 y. Michigan starts with a little bit less, but increases at a higher rate, 0.6 million per year. When will both cities have the same number of people? We go minus 0.5 y, minus 0.5 y. We get 11.4 equals 9.9 equals, not equals, plus 0.1 y. And then subtract 9.9 from both sides. Uh-oh, my battery's dying. Hang on, guys. And, hang on, please don't disappear. Don't shut off, don't shut off. Okay. That goes away. 11.4. That's gonna give us 1.5 and 0.1. Y divided by 0.1 divided by 0.1, and the number of years is going to take for both populations to be the same. It's going to be 15. So 15 years. Both states will have the same amount of people. That's it. So now you have an idea of situations that can be translated to equations with variables on both sides.